Hello everyone, my report about how to detect herd effect in text. We have all seen herd effect. For example, in the microblog, an opinion leader expressed an opinion, which will make many people follow it. So, how to detect which statements are produced by the herd effect from the complex information flow, and how to find the source of the herd effect? For this problem, I built an idea. At first, let's think about how humans judge the source of an idea. When we want to retell an opinion, we often use similar expressions. So, how to detect the similarity between two statements? This problem is similar to search engines, so we can use a similarity metric with search engine. This metric is TF-IDF. For a sentence, we calculate the sum of all words TF-IDF value to determine whether the sentence is affected by herd effect. Let's give an example of the discussion on Putin sent conscripts to Ukraine. The sentence of low TF-IDF sum like right and the sentence of high TF-IDF sum like at right. We think right sentence should pretend to be affected by herd effect. I marked the words with high TF-IDF value in red. According to the previous assumption, if review B is affected by A, B will use a similar expression to A. So a word with high TF-IDF value is considered to be affected by herd effect only if it appears in more than 2 reviews. So for this example, we can ignore the words that have a high TF-IDF value but only appear once. Okay. The result is obvious. We believe that the reviews affected by herd effect use expression is row 2 to row 3 children instead of conscripts. It can be seen that is very reasonable. Then I searched the source of this expression, found that comes from the recent news of exchanged prisoners between Ukraine and Russia. Can be seen it's a successful example of this algorithm. Okay. Now, let's really introduce this algorithm. We detect the repetition of a high TF-IDF word of review I and all other reviews J in order of time. If repetition satisfies the threshold condition, J is considered to be affected by I, and then can form a herd effect chain with I as the high node. Running this algorithm will produce multiple cross-sized herd effect chain, and the whole chain will form the herd effect graph. This is herd effect graph generated by running this algorithm on the amazing shopping review dataset. This graph shows how these opinions interact. Although this method is very simple, however, it can provide a lot of help for public opinion monitoring. Current public opinion monitoring generally only detects a keyword on internet and then calculates the emotional tendency of the review containing these keywords. It's very naive. But after use our method, you can know how many opinions have emerged on the internet, where the source of these opinions, and how they affect each other. This provides a very effective tool for studying public opinion. Okay, in here, someone maybe have a question in mind. TF-IDF is a very unfashionable metric. Since we want to measure 2 texts, why not use Dr. Vector or more advanced language model? I take Dr. Vector as an example to explain this question. What is Dr. Vector? Generally speaking, it's an abstraction of text semantics, and we want to measure is whether the expressions of 2 texts are similar. Expression and semantics are difficult. Generally speaking, semantics includes expression. If you want to separate the expression from semantics vector, you need to do a more complex recoding. In contrast, directly use TF-IDF to calculate on discrete text is more efficient. Okay, thank you for your listening.